So remember we were doing Kramer's rule, and we said what you do is you create a coefficient matrix, and then you create a series of matrices, AX, AY, AZ, you find the determinants, and then you have to divide by the determinants. Okay. So here, my coefficient matrix A for this one is 12, -9, 4, -3. Okay? All right, now here, first let me find the determinant of A, and I get -36 minus -36 again, so my determinant is 0. Okay, so now, remember with Kramer's rule, what you have to do is, you have to do determinant of AX over determinant of A. Well, if this is 0, then there is no solution here. Okay? Yeah.
How do we find like AX, AY, just like the matrix?
So what you do is you have your coefficient matrix here, right? You have this coefficient matrix, and then you take, okay, so for AX, you substitute the constants into the X column, and then for AY, you substitute the constants into the Y column, and then for AZ into the Z column. Okay, and then you find the determinants of each one. Yeah.
Somewhat off topic, but when will we find out about the quiz?
I haven't started grading them yet,
Okay.
but I will soon because I think we're almost there where everybody took it. Okay, so take a look at this one. If we were to solve this by hand, right? I multiply this by -3, right? So what do we get? 12x minus 9y is equal to -5. And then if I multiply the bottom row by -3, -12x plus 9y is equal to -33. And then you get 0 equals -38. So do you see how it's a no solution? And, Kramer's rule just told us that. Okay?
Well, that's a lot easier. If I know that in algebra, it's so much easier.
Yeah. Yeah. Committee is planning an event for 400 guests. The guests can choose one of the 3 options of dessert shown below. The chef must spend 5 minutes on each pie, 8 minutes on each trifle, and 12 minutes on each cheesecake. So those are the 3 desserts. The total cost of the desserts was $11.70, and the chef spends exactly 45 hours preparing them. Use Kramer's rule to determine how many servings of each dessert were prepared. All right, so 400 total, right? 400 total guests, so there have to be 400 total servings of the 3 of these, okay? Now, so we have to break this down. Okay, so what is it that we need? How many servings of each dessert was prepared? That's how we need. That's what we need. So we need to know how many servings of the pie, how many of the trifle, how many of the cheesecake. So there are 3 unknowns here. Hang on, I'll get you in a minute. There are 3 unknowns that we have to solve for. If you have 3 unknowns, you must be able to come up with 3 different equations, 3 unique equations. Otherwise, it's unsolvable. At least 3 unique equations. Okay, yes.
So you would assign like x to pies and
right.
y's to trifles?
Right. So here's what I'm going to do. I'm going to make it a little bit simpler. So why don't we say P is the number of servings of pie, and T is the number of servings of trifle, and C is the number of servings of cheesecake. And so we need, okay, there are going to be 400 guests. Now let's read this over again, knowing what we need to find. There are 400 guests. The guests can choose, okay, one of each. Okay, so the chef spends 5 minutes on each pie, 8 minutes on each trifle, 12 minutes on each cheesecake. Okay, so we have some time, amounts here. The total cost is $11.70. And then he spends exactly 45 hours preparing them. Okay? All right, so now we need to sort this out. Okay, so first of all, number of servings of pie plus number of servings of trifle plus number of servings of cheesecake. And then we need a total of 400 of them. So P plus T plus C equals 400. Okay? Right? Okay, now. And then we have some discussion about like time. So the chef spends 5 minutes on each pie, 8 minutes on the trifle, and 12 on the cheesecake for a total of 45 hours. Okay? So now let's write an equation for the time that's used. Okay, so 5 for the pie plus 8 for the trifle and 12 for the cheesecake. These are minutes. He spends 45 hours, which is 2,700 minutes. If you wrote 45 here, you're already done. Okay, it's already wrong. So make sure that your units match up. So 2,700 minutes, huh? Yeah. Or if it's not, it'll be, numbers that we can do on our own. Okay, so now there is another piece of information that the total cost was $11.70. And you see here, it tells you, how much money is spent on each one. So we have 3P. This one appears as a 5. Let me just write that better. Plus 2.5T plus 4C is 1170. Okay, there we go. And now we're supposed to use Kramer's rule to solve this. Okay, so this is probably the more challenging part, and then the rest is you just apply Kramer's rule. Okay, so again, like I was saying yesterday, if I had to, I only have like so many problems that I could put on a test, right? I wouldn't want to waste one. Rather than waste one saying, okay, use Kramer's rule to solve this matrix, use blah, blah, blah to solve this matrix. With this, I could test a whole bunch of things in one shot. Okay? All right. So Kramer's rule calls for the coefficient matrix 1, 1, 1, 5, 8, 12, 3, 2.5, 4. Okay. We need the determinant of this. If this is on the calculator section, you just put it in your calculator and you say determinant, blah, that's how you do it. If you have your calculator available to you, don't waste time doing determinants of 3x3s by hand. Okay? So 6.5. Because I plugged it in the calculator. All right? Yeah. Now I need A sub P. Okay? A sub P. So I'm going to leave, I'm going to substitute the constants for the first column. And then put in the rest. So 1, 8, 2.5. 1, 12, 4. So the determinant here is 1,430. Huh? Yeah, I'm plugging all these in. So calculator here. Calculator here. Huh? Yeah. Okay. Then A sub T. Now this first column is the same as A. The last column is the same as A, and only the middle column will get the coefficients. Yeah.
For A sub T, is that 1430 or
30. So here A sub T is gonna be 910. Okay? I plugged it in my calculator. Did you guys see me? I did. Okay, I know I'm quick. Okay. And then A sub C The first two columns remain the same. And then I plug the coefficients in the last column. The determinant, I plugged it in my calculator. Look, I'm plugging in, I'm crunching numbers, is 260. It would be like very small numbers that you could, I mean, no. It's too time consuming. It's a waste of time for you to have to do 4 determinants of a 3 by 3 for one problem. But I will ask you to find the determinant of a 3 by 3 by hand. That's a given. That's like a separate question of its own. Yeah. Okay. So now to find P, I do 1430 over determinant of A, which is 6.5, and P is 220. Then T is 910 over 6.5. T is 140. Okay. And now, look, I can already see that, wait a minute. Right. So look, remember, okay, so I could do the same thing here for C, but I know that P plus T plus C was equal to 400, right? So here I already have how much? 360. So C must be 40, right? Like, listen, you can do it any which way. All right, just get that C is equal to 40. I'm just showing you that all of this is all connected. Of course, if you did 260 over 6.5, you would get 40, right? But just know that, you know, all this works together. So now we made 220 pies, 140 trifles, and 40 cheesecakes. Yeah. Numbers, but similar. You will actually, okay, so this is number 54. This is 6.1, number 54. There is a similar problem, I think, on 6.3. I don't know, but and then we'll solve a couple more before the test. But no, another one. Let's do this one first, and then I'll let you know the rest. Okay. So take a look here. A parabola passes through 3 points shown on this graph. Write a system of equations that can be used to find the equation of the parabola in the form f of x is ax squared plus bx plus c. Okay, so the 3 points that were given here are -2, -5, -1, -6, 1, 4. In each of these, you have an x and a y coordinate. Okay? So now, for part A, you're told that you need an equation in the form of f of x, or y, equal to ax squared plus bx plus c. Okay? So, what you're going to do now is you're going to plug each one of these into this equation. Okay? Now, here, -2 is x, -5 is y. So if I'm going to plug it in here, y is -5 equal to a times x is -2, so -2 squared, plus b times -2 plus c. Does anybody have any questions on where we got that from? Okay. If I were to simplify that, I get -5 equals 4a minus 2b plus c. Okay, now I'm going to do the same thing, but for this number. No, it's x's squared. So it's a times negative 2 squared. So now I'm going to do the same thing, but for negative 1 and negative 6. So y is negative 6 equal to a times negative 1 squared plus b times negative 1 plus c. When I simplify that, I get negative 6 equals negative a minus b plus c. Ooh, positive a. Okay. Next, I'm going to plug in the last number. Y is 4 equal to a times 1 squared plus b plus c. Is that, we're good here? So I get that 4 equals how much? A plus b plus c. So look, I have 3 unknowns here, a, b, and c. And I have 3 unique equations, 3 different equations. 3 equations, 3 unknowns, I can solve this. So write a system of equations that can be used to find the equation of the parabola. I just did that. I just wrote a system of equations. So this is the answer to part A. Okay? You can write negative 5 equals blah, blah, blah. Or you could write, 4a minus 2b plus c equals negative 5. It's the same. So basically, that's part A. Part B says use matrices to solve the system of equations that you wrote in part A. Okay? So part B, we're going to use matrices to solve this. So it's going to be 4, negative 2, 1, negative 5, right? Because the constant goes on the other side, remember? So 1 minus 1, 1, negative 6, 1, 1, 1, 4. If you feel like you're going to get confused, write the equations in the other direction so that the constants are on the right side. Now, if on a test or a quiz, or on the test, since that's what we have left, if the question specifically asks to use a certain method, then you have to do that. If not, then you're on your own. I mean, it's up to you what method you want to do it. This was in section 1, so back then you would have solved it using Gaussian elimination. All right? Now you could solve it in whichever way you want. What do you mean? I don't know. You're definitely going to have like one of you. So once you have the matrix, it really shouldn't make a difference. But I'm an equal opportunist when it comes to these. So you'll definitely have a Kramer's, inverses, or whatever. Okay? All right. So how do you guys want to solve this one? What method do you guys want to use? Okay, let's do Gaussian. I want to do Gaussian as well, actually. Yeah.
You're not going to make us do this on a test with 3 by 3 matrices, right? Because we don't know how to do. Because you need a calculator.
Okay, so if I tell you to do something that requires a calculator, it'll be on the calculator section.
Like this does require a calculator.
Not if you do Gaussian. Let's do Gaussian. So let's do Gaussian.
But this is the one where Gaussian is the one where we have to just have one all the way.
Right. So I want to make these ones. It's actually very easy to do Gaussian here. So if I want to get rid of the one that I've circled here, what am I going to do? I could do row 2 minus row 3. And I get 1 minus 1 is 0. Negative 1 minus 1 is negative 2. 1 minus 1 is 0. Negative 6 minus 4 is negative 10. Now, how about in the same step, we also get rid of this one? Okay, how can I get rid of that one? R1 minus 4R2. Okay, yeah. You can do anything you want. It's just how efficient is that going to make the problem? Yeah. Okay, so 4 minus 4, that's a 0. Now here, negative 2 minus 4 times negative 1, that's positive 2, right? So R1, so it's R1 minus 4 times R2, so that's a 2. And then the last one will be 3. No, because it's, yeah. No, it'll be negative 3, you're right. So then R1 for the last constant minus 4 times negative 6, that's negative 5 plus 24, 19. Let me write the last row back. I get 4, negative 2, 1, negative 5. Okay.
When you're at this step, you can never combine rows 1, row 3, right?
It wouldn't be wise. Yeah, it wouldn't be wise. When you're at this step, the wisest thing to do is work with row 2 and row 3. Okay? So now if I want to get rid of this one, all I have to do is add row 2 plus row 3. So now I get 4, negative 2, 1, negative 5, 0, 2, negative 3, 19, 0, negative 1, 0, 0, negative 3, 9. Now, is this in row echelon form?
No.
No. What do you need to do to put it in row echelon form? Divide everything so that the main diagonal is 1, right? Now, let's divide this row by negative 3. Then I get, hang on, 4, negative 2, 1, negative 5, 0, 2, negative 3, 19, 0, 0, 1, negative 3. Okay? Now look. If you're not specifically asked to reduce and put in row echelon form, like you were on the quiz, if it's just for you, I'm fine if you leave it this way and start doing your back substitution. Okay? Because if I divide the top row by 4, I'm going to get fractions here, which I don't need. I'm going to get fractions here, which I don't need. So I can just start doing my back substitution here. Okay, so remember this was the A column, the B, and the C column. From here, this tells me that C equals negative 3. And then the second row tells me 2B minus 3C is 19. 2B minus 3 times negative 3 is 19. C was negative 3. So 2B plus 9 is 19. B equals 5. And then it turns out 4A minus 2B plus C is negative 5. 4A minus 10 minus 3 equals negative 5. 4A equals 8. A equals 2. Did I do that right?
Yeah. Can you figure out that B was 5 earlier on? Because we already had negative 2. We had it already Y on its own in the middle of the matrix.
Yes. That was, where was it? Where did I?
It was on the second step.
Yeah.
Okay.
Yeah, you could do that. Okay, so now A, B, and C are these. Okay, but what? Okay, let's go back to the problem. It says use matrices to solve the system of equations, which we just did. So it's 2, 5, negative 3. And then what does C say? Use the solution you found to write the equation that fits this parabola. So remember, where did all this come from? It came from the fact that, so this is part C. F of x is equal to ax squared plus bx plus c, right? Okay, what's a? 2x squared plus 5x minus 3 is f of x. That is the equation to that parabola. Isn't it cool? It's so awesome. That's how you solve, that's how you do it. Like if you have a parabola and you can figure out, 3 points on the parabola, that's how you can find A, B, and C. But you need 3 points. You can't get away with 2 points. You need at least 3 points because 3 equations, 3 unknowns. Okay? So that's how it's done. Pretty cool. Okay. All right, so that's that. And so this is on page 384. If you have the 3 coordinates of the vertices of a triangle, 6.2, right? Given the coordinates of the 3 vertices of a triangle, you can find its area, all right? Now, okay, I get it. For 45, it might be, you could do it like, half base times height, because look, this is a vertical line, and then the height is a horizontal line, fine. But, for ones that are not, like number 47 or number 48, you would have to like do the distance formula, blah, 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 and, and that's just, it's not as fun. Which one had I assigned for homework here? 45? Okay, so let's do 45. Sure. We could do a different one. Let's do 47. I do like 47 too. Okay. So 47, so this is 6.2, number 47. So the vertices of the triangle are, let me try. Oh, what happened? So the vertices are -3, 6, 3, 5, and 0, 1. All right, so the way to solve it is you write a matrix. Let's call the matrix not A this time. Let's call it M, okay, matrix M. So what you do is you list the 3 vertices. So -3, 6, and these become the first 2 columns of your matrix, 0, 1. Now, I need to make this a 3 by 3 matrix. I have 2 columns. I need a 3rd column. For the 3rd column, in order to find area, you always put in 1s. Just trust me on this. There is a long proof using like parallelograms and things like that, but we're just going to go with it now. Okay? It's actually a really fun proof, but it's okay. And 0. Okay? And then once you have M, you can find the determinant, and actually the area of a triangle is half times the determinant of A. But area must always be positive. I'm sorry, the determinant of M. Yeah. Area must always be positive, right? Now we know determinants can be negative or positive. In order to not create any problems for ourselves, we have to put the determinant in absolute values. Okay? So it's half times the determinant of M. And actually, you know what? Let's find the determinant by hand this time. So I have -3, 3, 0, 6, 5, 1. Okay, so this way you have -15 plus 0 plus 3. And then if I have to go the other way, it's -0 minus -3 minus 18. This is the determinant of M. Minus 18. Because this way is always negative.
Oh, okay.
So this is -15 plus 3 plus 3 minus 18. So what is that? That's -15. Another -15 is -30, -27. Okay. Area then is half of the absolute value of negative 27. So 27 over 2. How does that sound?